Okay, so I'm gonna go ahead and work this exam. Nothing special here, just I'm gonna work it. And I'll kind of talk through some, common errors that I saw that you might want to be aware of moving forward. I am going to do this entirely in symbols. I'm not going to use these numbers right here. These are just the numbers that they gave me. Obviously, they gave you a different set of numbers. Okay, so first, for part A, we're going to draw the free body diagram of the beam. So what you're going to do for that is you're going to draw the beam and nothing else. Okay, so here's the beam and nothing else. I'm not using a ruler at the moment. It's pretty straightforward to just do that. And then what we're going to do is we're going to draw all the forces. Okay, so we've got this one. That's F1, F2, F3, F4, and F5. And this is a rough sketch. So, I mean, ideally we would make these guys the appropriate distances apart. So we can do that. We can label that. That would be helpful for us to work the problem. And what's nice about this is once you've done this, there's no reason to ever look back at the original diagram. You have included everything that could possibly exist. Okay. Now at point A, there's a pin connection. So we're going to replace that pin with two forces. Okay, so because that pin could be pushing on it in the AY direction, and it could be pushing on it in the X direction, so AX. Okay, now AX is going to end up being 0, so that's a little bit redundant, but we still should draw it. And then at B, there's a cable. And the interesting thing about a cable, of course, is a cable is only capable of pulling. You can't push with a rope or a cable, right? It's just going to bend. So we know that it's in the negative direction, so we will draw it as such. And tension in cable BC, so we'll probably call that TBC or maybe just BC. Let me just call it TBC, tension BC. That'll kind of remind me as I work through the problem that this is a tension and that there's no chance that it's going to, that it's not going to, if it ended with a negative sign there, then that would mean I drew the arrow in the wrong direction. And since a cable is not capable of pushing, then there's something really wrong. Okay. All right, so that's really how you do it. I will note that you could have, as an alternate way of doing this, instead of doing AX and AY at that location, you could have done just an A with an unknown angle, theta, if you wanted to. Okay, and that would basically take care of AX and AY. The reason that we don't generally do that is, well, it's just messy, right? It's a little bit harder to work on. But it doesn't really help you because you still have two unknowns. You still have A and you still have theta. So it's really, it's not really encouraged to do that. In fact, I would heavily discourage you doing that. So let's just erase that and pretend we didn't see that. Okay, just kind of food for thought. Okay, determine the reaction at A. Okay, so A, that means we need AX and AY. AX is actually pretty simple. So for AX, we'll just do the sum of the forces in the X direction equals 0. And so that's AX, and I'm looking at my free body diagram. Okay, we're only going to look at this free body diagram, and you don't see any other forces in the X direction, so AX equals 0. Okay, so that's our answer. All right? All right, now we have to figure out AY, and we try the same thing, summing the forces in the Y, but the problem with that, of course, is that there's two unknown forces in the Y direction, the AY and the tension in the cable. So that's not really going to work. So instead what we need to do is a moment. And if I do the moment around point A, that's not going to have AY in it, right? Because AY is going to pass right through our point. So instead we're going to choose to do our moment around this point, which I believe is point B. Yeah, point B. So let's sum our moments. Let's sum our moments around point B. And those are going to equal 0 because this thing's not moving. And all right, so now we just need to do each force and its moment arm. So we have F1 times its moment arm, which is 6 inches plus 8 inches plus 8 inches plus 6 inches. So that's 28 inches. Okay. Note, we could convert this to feet. In fact, normally I would encourage you to do that. However, if the whole problem is worked in inches, you'll see the inches will just end up canceling out. Okay, so we're going to do, let's see, what direction is that? So that's going to cause it to spin this way. So that's counterclockwise, so we'll give that a positive sign. Okay, and then we'll do F2 times its moment arm, which is 6 plus 8 plus 8. So that's 14 and 8, that's 22 inches. Okay, and then we'll do F3. Okay, note all of these are causing it to spin the same way around this point right here. Okay, F3 is going to be 6 inches plus 8 inches, so that's going to be 14 inches. Okay, and then F4 plus F4, which is just going to be those 6 inches. 6 inches. And then we've also got AY, so that'll be minus AY times those same 6 inches, right? Because it's 6 inches that way, okay? And notice we don't worry about F5 or TBC because they pass directly through that point C. So we say equals 0. And if we rearrange this, we end up with something that looks like this. AY equals, well, F1 times 28 inches plus F2 times 22 inches plus F3 times 14 inches plus F4 times 6 inches, all divided by 6 inches. So there you have, you see the inches on the bottom and inches on the top. So inches are going to cancel out. Okay, so if you plug in, your numbers from your exam, this formula will give you the answer that you should have gotten. Okay, I created an Excel spreadsheet so that I would notice what F1 through F5 were on your exam, and I would just type them in, and then it would spit out what the answer would be for the entire test. That's really the only reasonable way to grade it. Okay, so that said, now we're gonna move over here, determine the tension in cable BC. So if we look up here, now we know AY. Okay, so determining the tension in BC is, well, I guess the easy way to do it would be the sum of the forces in the Y direction, because we know AY at this point. So I could say the sum of the forces in the Y direction equals 0. Okay, and if I work that out, well, let's see here. I've got F1 through F5, so those are all down. So negative F1 minus F2 minus F3 minus F4 minus F5. So those are all downwards. Plus AY minus TBC equals 0. Okay, so we'd want to solve for TBC there, which is pretty straightforward. We just moved over to the other side of the equation. And then we'll end up with TBC equals, let's see here, it looks like it's going to be AY minus all those others. AY minus F1 minus F2 minus F3 minus F4 minus F5. Okay, and that's the way that most of you guys did it, did this problem. And what you'd have to do is you'd have to take your answer from up here and plug it in right there. Okay, and that's the way that most of you guys did it. When I did the key that I'm going to post online for you guys, I actually did it as a sum of the moments. So I took the moments around point A. And you also could have done it that way. So if we sum the moments around point A equals 0, then what we could have done is we could have said, okay, well, let's see, that gets rid of F4, AX, and AY, because all of those pass through this point. And so I'd be left with, let's see, F1. Okay, that's going to cause to spin in a negative direction times, let's see, 8 plus 8 plus 6, that's 22 inches. Okay, minus F2, same direction of spin, times 16 inches, minus F3 times 8 inches, okay, because that's that distance right there. And then AX, AY, and F4 don't matter. And then we've got F5 and TBC both causing it to spin the opposite direction, and they're 6 inches away that way. So we're going to go plus F5 times 6 inches. Plus. And plus TBC times 6 inches equals 0, right? Okay. And we could rearrange all of that and solve for TBC. And we would end up with, let's see, okay, TBC equals F1 times 22 inches plus F2 times 16 inches plus F3 times 8 inches minus F5 times 6 inches Okay, and then we'll divide all of that by 6 inches. Okay, notice those inches are going to cancel out for us. Okay, and it's interesting because it doesn't look, so that's just an alternate way of doing it. And if you were to plug in the numbers here, and you were to plug it to to this solution right here, let's call this solution, let's call it, I don't know, let's call it M, and we'll call this one N. If you were to compare those two solutions, you'll find you'll get the exact same answer. Yeah. So yeah, that's definitely it. Yeah. Cool. All right. So that's how you work that. Okay. You could have done it either way. I ended up doing this way on my key, although I think the way that most of you guys did it was like this, which I think is actually easier. Okay. And the nice thing about that is, that was the first 3 questions. Okay. And fairly straightforward. Most of you guys did really well on those. By the way, I was really impressed with you guys on this test. Now, normally when a class does well, or when a class does poorly, I take it on the chin. I really cheer for you guys, and I usually feel like it's a reflection of me. On this test, on this semester, this rough semester that we're having with all the difficulties, really, all the credit for the good things go to you guys. I'm trying, but you guys are getting your information. Somebody else is doing the lectures, which I don't feel bad about, but it is it does mean that you're not getting your information from me. So my hat's off to you guys. You're doing really wonderful work right now. So all right. Anyway, so we're going to draw the free body diagram for this rod. Okay, noticing that we've got cables BE and BD. And we've got a pin connection at A, okay, or ball and socket joint, okay. So basically, there won't be any moments in this problem, which is nice. We might have some moments, but there's no, no one's applying a force on this thing with a wrench or something. All right, so to draw the free body diagram, we're basically just going to redraw our picture essentially. Here's our beam. Okay, we're not going to draw anything else. And then everywhere we're attached to the world or there was a force, we need to draw those things. Okay, so there's a weight right here. Notice mine is a 910. You may have had a different number. I'm going to calculate this whole thing with the letter W. Okay, as you can imagine, everything's going to end up being proportional to W. Okay, so we've got in this direction we've got a Y, right? We've got 3 directions at the joint here. We've got see here, this is going to be the AZ direction. And then we're going to have AX, which of course is the hardest one to draw in this case. So that's AX. Okay, and then we're going to have these tensions. And so one tension is going to be kind of like, I don't know, you're right up in here. Okay, and that's going to be TBD. TBD. And then one tension is going to be going like this. And that's going to be TBE. Okay, so those are the tensions in the lines. And I'm going to move this one away so it doesn't confuse me as to which is which. TBD. Now, some of you guys drew some little dotted lines to kind of show where these things were headed, and that's fine. Just if you want to put some geometry on your free body diagram, that's good. But you really just want the object and the forces that are acting upon it, nothing else, okay? In this case, because the geometry is difficult enough, I'm not going to redraw the diagram. I'm just going to, use this for my geometry, just because, okay? Because that's going to make things a little bit easier. Okay, I'm going to notice that right off the bat, so before I really do much on this problem, I'm going to start with an aside, as I call it, an aside. And what I want to do here is I want to note that the only forces that I have that are not in the X, Y, or the Z direction are these tensions, right? They're the only ones off on an angle. So I want to kind of split them apart as best I can into things that are a little bit easier for me, right? So TBD and, okay, so I'm going to split that thing apart into I, J, and K. Okay, so what I'm going to note is that TBE, if I look over here on the drawing over here, so let's see here, TBE, or TBD, I guess. We'll start with BD, whatever. Start off with this one. Okay, so what direction is it going? Well, let's see. In the x direction, it's going from here to there. Okay, 6 feet. 6 feet. And that's a negative 6 feet because positive x is this direction. So I'm going to put a negative 6 feet. Okay, I. Okay, in the y direction, okay, we're going to go up here. Okay, and that looks like it went up 7 feet in the positive y. So we're going to call that plus 7 feet in the j. And then in the k direction, it's going to go this way, and that's positive because z goes this way. So we'll go plus 6 feet in the k direction. Okay, and now, of course, we have to normalize that, right? Because it's not going, this is really just a similar triangle. So we have to normalize that, right, by the length of this string right here, this cable. So we'll normalize it by using Pythagorean theorem. We'll do the square root of 6 inches squared plus 7 feet squared plus 6 feet squared. Okay. So what I'm going to end up with is TBD equals, I'm going to keep this in fractional form, 6 over 11, so that the bottom is an 11. Negative 6 elevenths I plus 7 elevenths j plus 6 elevenths k. Okay, so that's TBD. Okay, now I'm going to note that in this case, TBE is the exact same thing. Oh, sorry, I forgot. This is being multiplied by, this is my most common error. It's being multiplied by the magnitude of TBD, like that. Okay, I'm going to note that TBE is the exact same, except for the fact that in the z direction, it's going negative, right? So basically, it's going to look exactly the same, negative 6 over 11 I plus 7 over 11 j minus, okay, because the k direction is negative 6 over 11 k, okay, tau be, or excuse me, TBE, okay? And so this is an aside, and now everything is in x, y, or z format. Okay, so that makes things a lot easier. So I like to just kind of get that out of the way real quick. Okay, so now what I want to point out is we've got, let's see, how many unknowns? Well, we've got 1, 2, 3 A's, and 2 tensions. So I've got 5 unknowns. So I'm going to need 5 equations. Okay, and I'm going to start with the easiest one, which is the z direction. Some of you didn't even bother, really. You were just like, well, the sum of the forces in the z direction. Well, is that so simple? Well, let's see here. So we've got, let's see, in the z direction, we've got AZ. Okay, and that's a positive because I made it positive. Okay, and then I've got TBE, the k portion of TBE, and the k portion of TBD. So I can say plus 6 over 11 times TBD, okay, plus or minus 6 over 11, minus 6 over 11 TBD, okay, equals 0. Okay, now I will say that right off the bat, if you're using just kind of like, I don't want to call it common sense, but we could call it common sense. We could just note that that TBD and TBE by symmetry are going to be equal. Okay, and if you did that, then you could say right off the bat that AZ is going to end up being 0. Okay, we will assume that we were not able to recognize that this thing is symmetric. Okay, and so let's leave it like that. Okay, so we can't solve for AZ yet. Okay, even though in your heart of hearts you should know that AZ is 0. Okay, just trying to get you to start thinking with, get some intuition here. Okay, so let's do the sum of the forces in the x. Sum of the forces in the x equals 0. Okay, what forces do we have in the x direction? Well, we've got ax. Okay, I've drawn it in the positive direction. And then I've got the x portion of both of these tensions pushing it back into the wall. Okay, so that's going to be the x portion of TBD, which is going to be minus 6 over 11 TBD. Okay, and then minus 6 over 6 elevenths TBE. Okay, magnitude equals 0. Okay, and the nice thing about that, and this should make sense to you, both of those cables are pulling it back into the wall. Okay, so this AY is pushing back. It has to equal, you see this AX has to push back just as hard. Okay, fortunately, the unfortunate part about it is, again, we have an equation that we cannot solve right off the bat. Okay, even if I know that they're symmetric, I can't solve it yet. Okay, so let's try the z direction. Okay, the sum of the forces in the z direction equals 0. Okay, now again, we're looking at our free body diagram. The z direction, we've already done z. Let's do y. Okay, let's do the y direction. Okay, so the y direction in this case is upwards. Okay, and that in this problem seems like it's going to be the most important one, because the force that we're fighting against here is that weight. Okay, so I've got AY. I've got the y components of these tensions. Okay, and they're both upwards, plus 7 over 11 TBD plus 7 over 11 TBE. Okay, minus the weight equals 0. And again, looking at these equations, everything gets a lot simpler if I know that TBD and TBE are the same. But they won't always be the same. So I'm going to pretend like we don't know that. Okay? So now we're kind of like, okay, well, this is getting to be very, very, difficult. Because I've got 3 equations. I've got 5 unknowns. I need 2 more equations. And so what I want to do now is I want to start doing moment equations. Okay? And the problem here, or maybe not the problem, but yeah, so let's start with, we're going to do moments around A. Okay, so I'm going to do the sum of the moments around A equals 0. Okay, and I'm choosing A because I don't want to have to deal with AX, AY, or AZ. I'm just going to let those guys, go away. I just don't want to think about them. They're, let's solve for these tensions. And once I get the tensions, AX, AY, and AZ will come out of that equation, these 3 equations that I just showed you. Okay, so the first thing, so I'm going to do this as, so we have to choose directions, or we can do it all at once. And I'm going to choose directions because to me that's just the easier way to do it. You may do it in whatever way you want to do it. Okay, so the first thing I'm going to do is I'm going to do in the let's do the Z axis. Okay, so we're going to do K like this. Okay, so what I want to imagine is I'm staring, I have my eye right here, okay, and I'm staring straight down this axis. Okay, and as I'm doing that, I want to think about these forces, okay, and what they're doing. Okay, so the first force, okay, and I'm doing it at A, so I don't have to deal with any of those A forces. You know what, maybe I should do this over here. Okay, so let's do it over here. Okay, so here's my axis. Okay, this is my Z axis. And I'm looking for things that are going to cause this thing to spin. And look at this. This weight right here, you should be able to note that this weight is going to cause it to spin this way around that axis. Okay? And it's exactly perpendicular. So since it's perpendicular, I just need to, its distance, right? I need to figure out what that direction is. Okay, so remember my eye is right here. And what does it see? It sees something turning clockwise. So we're going to make that a negative. So negative weight times that distance, which is, it looks like it's about 10 feet. Okay, 10 feet. Because we can see that right here, 10 feet. Okay? So then, both of these tensions, they're pulling upwards, okay? But the only portion of them that I'm concerned with is the portion that's going straight up, right? Because one portion is sliding back along this wall and it's going right through A, and I don't care about that portion, right? And the other portion is going to be pulling kind of into or out of the board, depending on which one we're doing, and it's going parallel to this line, so it's not going to cause it to spin around that line. So the portion that's going straight up, okay, it's going to cause things to spin counterclockwise. So it's going to get a negative sign, and it's just the y component. Okay, so we're going to do the y component plus 7/11 of TBD. Okay, and now we need its moment arm. Its moment arm is 6 feet. 6 feet. Okay, and we're going to need a little bit more space because this is the K equation, but it looks like we don't have enough space. So I'm going to give it a little bit more space. And similarly, the TBE times 6 feet. And then we'll close that equals 0. Okay? So that is the sum. Oh, excuse me. That's not it. That's just the K portion, right? So those are the Ks. Okay? And then I'll go ahead and do the J's. Okay? Excuse me, not the J's. Are the J's? Yeah, the Z direction. Wait, what did I just do? I just did the Z direction. Okay. We want to do the Y direction, right? So we want to do now the things that are going to cause it to spin around this axis. And again, I want to pretend that I've got an eye, and I'm looking down from the positive axis. And what direction are those forces going to cause things to spin? Okay, so I'm going to open the parentheses, and let's see. So the first force that we're going to worry about here is this TBE. Okay, and I want to know about this portion of that force. Okay, notice that it's going to cause things to spin this way around that thing. Like if I'm up here and I'm looking down, to me it's going to look counterclockwise for TBE. So I'm going to go minus, okay, let's see, this is the Z component, so that's going to be 6/11 TBD. Okay, and again, that moment arm is 6 feet. 6 feet. Okay. Now, on the other hand, then I need to account for the TBD, and it's the same sort of thing, except it's causing it to spin the opposite direction. Okay, which makes sense. Okay, they're both pulling in opposite directions, so that's going to cause you're going to see a positive spin, plus 6/11 TBE. Times 6 feet. Okay. And we'll go ahead and call as that, well, that's going around the y-axis, so that's going to get a j. That's going to be equal to 0. Okay, so these are 2 more equations. We've got the K equation and the J equation. So now I've got my 5 equations. Okay, and this is how I graded you. You know, I looked for these equations, you know, to give you as many points back as I could, right? So everybody had different numbers, but if you could get those equations, it's 1, 2, 3, 4, 5 points, right? And then these were another point. Okay, that's, was my hope that you would get those equations. Okay, to solve this, we're going to look for the easiest ones to solve. I already know that I can't solve 1, 2, or 3. 4 can't be solved, but 5 can be. And 5 is going to make things, 5 is the key. So if I look at 5 right here, then you'll notice that, I can divide both sides by 6, and the 6 goes away. It goes on the bottom of a 0, doesn't matter. I can multiply both sides by 11/6. Boom, those are gone. And then I can bring TBD onto the other side, and what I end up with is TBD equals TBE, which is a really great result. It's really, really helpful. Okay, so while that doesn't give us any values, it does help us solve some of the other problems. Okay, so for starters, I can go up to equation 1, and if TBD equals TBE, then this bit right here cancels with that bit, right? 611 TBD minus 611 TBE. If they're the same thing, it goes away. So AZ equals 0. AZ equals 0. Okay, so I guess we can like list all of our things that we want. TBD and TBE, right? We want the magnitudes of these. AX, AY, and Z. Well, maybe we'll just get them. We'll just get the magnitudes of those as well. Okay, so we got one down. All right, but the other thing we're going to do is we're going to go in right over here. We're going to use this fact over here in this equation, okay? Because all the k's have to sum up to 0. So we're going to end up with negative weight times 10 feet. Let's kind of zoom in. There's no reason for all this small print business. Okay, plus 7 over 11. Well, let's call that 42. Let's do this. Oh, the other thing I'm going to do is I'm going to divide feet from both sides, so I don't have to write feet anymore. Not that it's a big deal to write feet, because it's just a little tab mark, but, you know, sometimes it's the little things, right? So 42 over 11th times TBD. Okay, this one will also end up being 42 over 11th, but it's going to be TBD, right? Because I'm saying they're equal to each other. So really, I'm going to have twice as many of this. So I'm going to have 84 over 11. So let's make this 84 over 11. 84 over 11 is TBD equals 0. Okay. So if I rearrange this, TBD equals, let's see, we're going to end up with W times 10. So this is going to be 840. No, W. Yeah. It's going to be 11 over 84 times 10. So I guess it's 110 divided by 84. Okay. And I'm going to want to go ahead and simplify that because I don't feel like working with such a ridiculous fraction. Okay, so that's going to be 55 over 42 W. Okay. So that's how you'll know what your answer should be. And that, incidentally, would also be 55 equals TBE, right? Because these two are the same. Okay, so that's nice because, you know, now we're done with our tensions. Okay, not our intentions, but our tensions. Okay, so if I zoom up here, I'll go ahead and fill those two in. So these are 55 over 42 W, 55 over 42 W, 55 over 42 W. Now you might say, why didn't I put that in my calculator and end up with 1.3095? You could, but this is just a more exact answer, and there's no risk of getting any rounding errors. Okay, so now we're going to go over here, and I have to do sum of forces in the x direction. Okay, so I'm going to take this equation, I'm going to bring it down here, and I could do the same thing with y, but I'm going to do this one first. Minus 6 over 11 times TBD, minus another 6 over 11 TBE. So I'm just going to make it, I'm going to do two of those because we know that they're the same. So let's make this 12 over 11. 12 over 11 times TBD, which is 55 over 42 W. Right, now that's awfully nice, right? Equals 0. Because that's going to work out really pretty, right? So this is going to become a 5. 12 over 42, what can we do there? This becomes a 6, this becomes a 21, this becomes a 2, this becomes a 7, 10 sevenths. Okay, so AX equals 10 over 7W. That's nice and clean. Okay, so we'll go over here. We got 10 over 7W. Okay, now we're going to do AY. And I could say, well, AY plus 7 over 11 plus 7 over 11. So I'm going to make that 14 over 11. Okay, times TBD or TBE, either one, they're the same. So 55 over 42. W equals 0. And let's see, this is going to become a 5. 14 become a 7. This is going to become a 21. So if we rearrange this, I'll get AY equals negative, what's that, 35 over 21? No, 35 over 21 is 5 over 3, negative 5/3 W. Okay? So AY equals 5/3 W. 5 over 3 W, negative. Did I put the negative in over here? I did, okay. All right, and so those are your answers. And it should make sense that, everything is proportional to W. If you hang more weight on there, everything should increase, except for AZ, because, C has nothing to do with it. Okay? So that's whatever question this is, 2? 2, yes. Okay, easily the hardest one to grade. Probably, in some ways, ideally, if you were looking at this test and you were like, I think I'm going to have trouble finishing, this would have been the one where you would have gone, let's not work this one. Because if you look at the amount of effort went into this was only, one question. This one was 3 questions, right? Look at how quick this was. Okay. Anyway, all right. Determine the force in members BD and CD of the truss. Okay. Again, I'm just going to use P. I'm not going to use 43 kips. You guys all had different numbers. All right. So let's see. The first thing we want to do in all of these is we always want to figure out the external members. I will go ahead and draw a free body diagram because I want to encourage you guys to. And a lot of you guys don't want to do that, and it's going to bite you. I teach higher level classes, and I see it all the time. People don't want to draw a free body diagram, but I'm going to show you how easy it is to draw a free body diagram so that, please just do it. The paper is cheap. I mean, you don't have to draw all the internal stuff, right? Who cares? I mean, I'm not saying it doesn't matter, but there's no reason to draw it right now. Okay, this is a roller, so it can only act upwards, so that's going to be I'll call it HY. Over here we have a pin, so this is going to be AY, and this will be AX. Okay? If you wanted to, you could draw this internal stuff if you wanted to, but it's not technically important. Okay, but you see, this took me a split second to do. But what it does is it helps me a lot with solving the problem, okay? Because all the internal stuff doesn't matter. The only thing that matters is what's happening on the outside. And I just showed you everything that's happening on the outside, okay? So we want to know the force in members B, D, and CD, okay? So let's go ahead and do this. So let's do the external. So we can find the reactions. Okay, so some of the forces, so this one is I'm going to find the reactions. Okay, some of the forces in AX equals 0, so that's AX plus nothing equals 0. So good, we've got one reaction. All right, and now we'll do, in the Y direction is pretty straightforward. Sum of forces in the Y equals 0. We've got AY is up. HY is up, and we've got 2 P's that are down, okay? And unfortunately, can't solve that one yet. So we'll do the sum of the moments, and the easiest place to do the moments is at A, because that's going to get rid of AX and AY, because they both go right through there, okay? So we'll go sum of force moments in the A equals 0, and so I've got P times, it looks like we've got 10, 20 feet. Okay, and that looks like that's going to cause things to spin, in this direction. So that's what, a negative? Clockwise, that's a negative. Minus P times 1, 2, 3. So that's going to be 30 feet. Okay, and then we've got H plus HY, and that's going to be the full 1, 2, 3, 40 feet. Okay, equals 0. Okay. So if we solve this particular equation, basically this becomes negative P times 50 feet plus HY is 40 feet, and you rearrange that, and HY equals 5/4 P, okay? Okay, so if we plug that back in up here, then I'm going to get AY plus 5/4 P minus 2P equals 0. So AY is going to be equal to 3/4 P. Okay, there you go. So those are our reactions. Okay, so let's see here. Now we want to start looking at the truss itself. I don't think it's going to matter, but before I start working on the truss, I want to find some zero force reactions or zero force members. Do we have any of those? It's always a good idea because it could just make your life easier. And I want to note that there is one. If we notice, based on this joint right here, there's not going to be any force carried in this thing right here. So, I mean, if I wanted to, I could almost like erase it, and it wouldn't have any effect. Ultimately, as you guys will learn later in your structural careers, they do have some role. But basically, zero force member, you don't want to make very large at all, okay? Because it's not really going to support anything really, really important. Okay, so then the third thing we want to do is, well, we want to think about which members are we solving for here. We're solving for BD and CD. Okay, so let's see here, BD and CD. So BD is right here. Okay, so that's this one. And CD is this one. Okay, since for me, I want to do this all at once, right? I don't want to solve this whole truss. What I'm going to do is I'm going to cut it right here because that cut is going to give me both of those forces. Okay, so what I'm going to do down here is I'm going to do a free body diagram of that portion of the problem. Okay, so it's going to look like this. Let's see. Okay, I'll go ahead and draw even that zero force member. Okay, and it won't matter because in this case, the zero force member is internal. Okay, so here we go. I'll note that these two kind of pass up and they both run into this point over here, D. Okay, not that it's critical, but it is there. Okay, and so I'll note that at right here I've got AY, so I've got a 3/4 P right here. Okay, and then I've got, I'm going to go ahead and assume that these things are in compression just because, I don't know, why not? Okay, you can assume however you want. I generally like to assume compression just because pushing is kind of easy for me to think about it. So this will be BD. This will be, let's see, CD. And this one will be CE. Okay. And we have no other forces here. I will note that, when we go up to this original thing here, this is 7/5. This is 7/5, 7.5, and this is 10. So this one is 3/4 of that one, which means that this triangle here is a 3, 4, 5. Okay, and I'm going to use that throughout. Okay, some of you guys will prefer to use, so basically this is a 3, 4, 5. Okay, this is 3, this is 4, and this is 5. Okay, and this triangle is a 3, 4, 5. Okay? All right, so what I'm going to do now is I'm going to just think about each of these forces and try to use them to help me out here, okay? So in the x direction, I note that I've got 3 forces. So the x direction is going to be very difficult for me to work with, okay? So I'm not going to start with the x direction. I think I'm going to start with the y direction. Okay, so let's do sum of the forces in the y direction equals 0. Okay, so let's see here. Okay, so we've got 3/4 of P going up, 3/4 of P upwards. Let's zoom in. No reason to work so tiny. Why does it do that? All right, and then I've got this CD going downwards, right? So I've got minus some fraction of CD, right? Which fraction? Well, CD is the 5 side. I want the 3 side, so let's do 3 over 5, okay? You could also, for those of you who prefer, you could think of that as the sine of this angle, right, if you wanted to, right? Because that would be the opposite side would be the 3, and the hypotenuse would be the 5, right? So you could do it that way if you wanted to. Okay, equals 0, okay? So the cool thing about that is right there, we just solved for CD. Okay, we rearrange this, and CD equals 5 over 4 times P. Okay, and I got a positive sign, so that means I assumed the correct direction, so this is going to be compression. Okay, so now let's do the moments. Okay, the sum of the moments in the, I will go around a certain point. Now here the key is picking a point that's going to be easy to solve, okay? I could very easily, I could do point D if I wanted to. Okay, it doesn't have to be on the frame or, or in my free body diagram. I can choose any point I want. I could do that point. That would be fine. But I don't know. What's the problem with that? Well, the problem with that is the thing, well, actually, it would work out just fine, except for the fact that this is the one that I'm looking for, right? I've always been looking for these two. So choosing point D is not going to help me get to my answer, right? So instead, I'm going to choose point C down here, because that point, okay, is going to get rid of CD and CE from the equation, but BD is going to be there for me to use. Okay, so I've got 3/4 P, 3/4 P, okay, times its moment arm, so that's going to be the distance from here to here, okay, and it looks like that's 7.5 feet, okay, and that's going to cause things to spin around that thing in a clockwise manner, so it gets a negative sign, and then I'm going to add, oh no, BD, I have assumed is going to cause things to go the opposite direction. So I am going to add. That's going to be BD times its moment arm, which is from here to here, which is going to be 10 feet, equals 0. Okay, so if we rearrange that and solve, we get BD equals P. Is that right? 7. All right, yeah, it didn't seem right, and that's because it's not right. Okay, so let's, I got my moment arms mixed up here. Okay, so this one right here, 3/4 P, is 10 feet away. Okay, and BD, which is up here, is 7.5 feet away. Okay, 7.5 feet away. Okay, so now if we rearrange this, we get BD equals P. Okay, and it's a positive sign, which means I assumed compression, and it is in fact in compression. Okay, so that's how you do that one. All right, let's see. Okay, let's go to number last. Okay, again, I'm going to solve it with the variables and not with anything else. Okay, so consider the structure. We've got P and we've got Q. Okay, draw the free body diagram of joint D and joint A. Okay, joint D looks like this. D, and I'm going to assume it's in compression. So I'm going to put a force here. And I'm going to assume everything's in compression because that makes my life easier. So this will be force AD, and this will be force CD. Okay, so that's joint D. Okay, and joint A. Joint A. Okay, and so A looks like well, that one shouldn't be so squiggly. All right, and again, I'm going to assume everything is in compression, like such. Okay, and so now I've got AD, I've got AC, and I've got AB. AB. Okay, and then I've got P going off this way. All right, so those are our two our two joints. Okay? All right, using the method of joints to determine the force in each member of the truss shown, whether it's shown, state whether each mention is tension or in compression. So let's see, what I'm going to go ahead and write out all the things I need answers to, and we'll kind of fill them in as we go. So I've got AB, AC, AD, BC, and CD, I think. BC and CD. Okay, so those are all the ones we need. Okay, so we've got a little area for our answers down here. Hopefully I left enough room to actually write them down. All right, so I'm going to note again from fractions. You know, we've got, this is a 7, 24, 25 triangle. Okay, so this is another special triangle. Okay, so this is 7, 24, 25. Again, you could just use sines and cosines if you prefer. Okay, you know, it's pretty nice. You know, if you do the sine of this angle, you're going to get 7 over 25. If you plug in 7 divided by 25 in your calculator, you're going to get the same thing as the sine of that angle. Okay, so that's how I'm going to use that. Okay, so we're going to go step by step, and I'm actually going to do this the way that I do this. You can draw all these free body diagrams if you want, but I usually do it on the truss itself. Okay, and so we're going to start. We'll get the external forces first. Okay, and so again, free body diagram. Okay, and again, you don't have to spend a lot of time on this. Okay, so there's no reason not to do this. Okay, I should time it to show that it takes about, I don't know, 10 seconds to do this. Okay, we've got, looks like we've got CY, and we've got BY and BX. Okay, a little intuition should tell us that CY is going to be very large. Okay, it's probably going to be twice Q. Okay, it is going to be at least twice Q, right? So if Q were the only force on here, if I were to cover up that P, then it would have to be twice Q because it has half the moment arm. But it's going to have an additional bit because of P, right? And it looks like, yeah, so we'll see. And that will end up being the case. But however, if C is up and Q is down and P is to the right, then that means BY is actually going to be negative, okay, because it's going to have to keep it from spinning the other way. So, but anyway, let's go ahead and solve these suckers. Okay, so I'll do sum of the forces. Let's start in the x because that's easiest. Okay, and so I've got bx plus p equals 0, which means bx equals negative p. Okay, sweet. Okay, let's do the sum of the forces in the y direction equals 0. And it looks like I've got by plus cy minus q equals 0. Can't solve that yet. And then we're going to do the sum of the moments. Sum of the moments, and the easiest point is going to be b equals 0. And so let's see here. So it's going to be cy times 2.4 meters. Okay, that's the distance from here to here. And that's going to cause things to spin this way around B. So what's that? That's counter, so that'll be positive. And then Q is a negative, so it'll be twice as far. So Q times 4.8 meters, because it's going from B to there. Okay, and then P is going to go up to there, minus P times 0.7 meters equals 0. Okay, so the nice thing about this is we can solve for CY. Also, all these meters are going to cancel out, okay, which is awfully nice. And CY then equals 2Q plus 7 over 24P. Okay, now you may not like that 7 over 24P or this thing, but notice, and this is one of the reasons why I like to use this triangle right here. I don't know why it's so jumpy. Is that the sides of this triangle are 7 and 20. Two of them are 7 and 24. Okay, so this very well, a lot of that could cancel out nice. Okay, and that's one of the reasons I use this. Anyway, regardless, let's go down in here and let's plug that back in up here. And I'm going to get by plus 2q plus 7 over 24 p minus q equals 0. Okay, so I'm going to get by equals negative 7 over 24 p minus q. Okay, so that's algebraically what this works out to. All right. Okay, so now what we want to do is we're just going to start working our way through this thing. And instead of drawing a whole bunch of free body diagrams everywhere, okay, I'm going to do it all up here. So first thing I'm going to do is I'm going to label some forces on here. So like right here, I've got negative P. Or I've just got P, actually. I've changed the direction, so now I just have P. In the y direction, I've got this thing pushing down. Okay, and that's going to be 7 over 24 P plus Q, right? And then at y over here, I've got this thing coming up. Okay, and it is going to be 2Q plus 7 over 24 P. All right, so there's kind of a lot to think about here. All right, so I'm going to zoom in, and I'm just going to look at each joint like really close, okay? So I'm going to assume that that breaks off right there. So now I've basically got a free body diagram, right? And what I want to note here, okay, is I'm going to think about this triangle here. Okay, this is 7, this is 24, and this is 25. Okay? Now, in the x direction, I've got 3 forces. I've got P, and I've got this one, and I've got this one. Okay, in the y direction, I've only got 2 forces. I've got this one, which I know, and I've got the vertical side of this one. So I know the vertical side of this one is 7, right? And it's going to be upwards. It's going to be 7/25 of that side, right? So if I want this side right here, this thing is going to be 25 over 7 times 7 over 24 P plus Q. Okay. Okay, let me reiterate how I did that. Okay. There are 3 forces on this thing, right? There's this force, which is only in the x direction. And then there's the y force here. Well, let's see. Let me back that up. Okay, so there's a force here going down this beam. That's in the x direction. And then there's a force going down this beam, which has an x and a y component. Because of that, I decided that I was only going to look right now at the y direction because this force doesn't matter in the y direction, right? So I'm trying to simplify my life, okay? So this force, on the other hand, it's got an x component and a y component. And I know it's going to have to be in this direction, okay? So it's going to have to be in tension. It's going to have to be pulling. And I know that on this joint right here, and I know that because this one's pulling downwards, okay? So this one has to pull upwards, okay? Because they have to balance, all right? So I know then that the upward side of this triangle is 7 over 24 P plus Q. Okay, that's the upward side of that triangle. Okay, which means basically by ratios, okay, if that's the 7 side of this triangle, I want the 25 side of this triangle, right? So then that means that this side is 25/7 of whatever this side is. Okay, so it's 25/7 of that whole side. Okay, so that means that this thing is going to be equal to 25 over 24P plus 25 over 7Q. Of course, it's a little bit easier if you don't have, and that, of course, is tension. Okay, it's a little easier if you don't have such ugly numbers to deal with, right? P's and Q's and whatnot. Anyway, so now I know this one is 25. Okay, so now what's this x component right here of this? Okay, well, that's going to be 24 over 25 times the hypotenuse, right? So I'm going to say this side then is going to be 24 over 25 times 25 over 24P plus 25 over 7q. Okay, so this whole triangle basically comes out to be, in the vertical, it's 7 over 24p plus q. Okay, we got that from down here. On the horizontal, it's 25 over 24p plus 25 over 7q. And then it's horizontal right here is going to be whatever this multiplies out to, which looks like it's p plus, let's see here, 24 over 7q. Okay? Boom. Okay? So all of that's not 100% necessary, but it's what we got. Okay? So I'm going to erase a little bit of this noise here, because this is really what we care about right here. So this right here is BA, or AB. So AB equals 25 over 24p. Let's see here. Oh, well, let's just do it up here. AB equals 25 over 24p plus 25 over 7q. Okay, unless I made a transcription error, which does happen, especially to me. BC, CD. Okay. Anyway, so I'm going to do this a couple of times, and hopefully this will make more sense when I do it the other times. Okay, so I know this is what's going on here. Okay. So hopefully this will make more sense as I do it more times. So I can say right off the bat that that's the case. So I can draw this arrow going this way right here. Okay. And so I know that that's going to be, this whole thing is 25 over 24p plus 25 over 7q. Okay. So there's no reason to bother erasing it. The thing to remember here, though, is what we already know is right here and right here. I already know those sides, right? This is the horizontal side, p plus 24 over 7q. And the vertical side is 7 over, sorry. And the vertical side is 7 over 24 p plus q. Okay. Yeah. Okay, so, all right, but we're still on this joint, okay? And I'm gonna kind of show you why I did all of this right here. Is because if I can kind of keep it in my head what the horizontal and the verticals are, a lot of times these numbers, they just kind of move around on us, right? They just kind of keep going. So now I've got this horizontal right here. I've got this horizontal right here, this negative p, okay? And then I've got whatever's going on in this thing right here, okay? And we'll note that this direction is stronger by 7 over 24q, right? So if I had p plus 24 over 7q, and I add this and some unknown, and they all have to add up to 0, well, the unknown has to be 24 over 7q. And it's going to have to push back, right? So it's going to be going the other way, right? So basically I need another 24 over 7q going the other way. So this thing, okay, is going to end up being in compression, right? And so we typically draw that like this. Okay, like this thing is pushing back. Okay, and this is 24 over 7q. Okay, so P plus 24 over 7q, those are both the things going to the left, equals P over 24 over 7q. Okay, that makes perfect sense. That makes sense, I think. Okay, so now let's go over here. Okay, so now I've got this 24 over, so now I'm looking at this joint right here, joint C. Okay, and I've got 24 over 7q acting on it to the right. And what's coming on the left, well, this is going to have to be, the only thing force I can come from the left is this one. So it's going to have to push. So basically I got 24 over 7Q pushing from the left. So from the right I need another push. So it's going to be 24 over 7Q from the right, okay? And that's going to push in both directions. So this is compression. So BC and CD are both in compression. So where are we? 24 over 7. Is it Q or P? I can't remember. Q. 24 over 7Q. Okay, so that's kind of interesting. Especially because Q is way over here, right? It's causing all of this to compress all the way down. Okay. Now, let's look at joint A. Oh, no, we still got to finish this joint, don't we? Okay, so in the vertical, well, this is pushing up with 2Q plus 7 over 24P. So this is going to have to push down the same thing. So this is going to be, it looks like it's compressing, right? Because it's pushing out. Okay, it's going to be 2Q plus 7 over 24P. Okay, so let's go over here to AC. 2Q, Q plus 7 over 24P. Okay. All right. So now we're getting pretty good, like we're getting up there. So now we've got this frame thing. We've got this joint here, A, which is easily the most difficult joint. So I think what I'm going to do is I'm going to come back to A, right? Because it's got all this stuff going on. If I'm working on a test and I got time problems, there's too many things going on at A. Let's go over here to this one. This one's easier, right? So let's cut this one here and cut it there. What do we have? We've got a Q coming down, and we've got a 7/24 Q coming in from the left. Okay, so first of all, we only have Q's to deal with, which is awfully nice. So let's go ahead and solve this sucker. Let's see, in the X direction or the Y direction, which one do you want to do? Well, it's pretty straightforward, actually, because we know in the Y direction it's going to be a Q going this way. And in the X direction, it's going to be 24 over 7 Q going that way. So we could, if we wanted to, do a little Pythagorean theorem here. Like I could say, okay, well, what is that, AD? Yeah, AD equals the square root of Q squared plus 24 over 7Q, if I wanted to. Come on. I got it. Low battery. Okay. Q squared. I could do that if I wanted to. But that seems kind of annoying. So I'm not going to do it that way. Right? What I'm going to do is I'm going to recognize that this is a triangle, right? So this is 7, this is 24, 25, and this is 24. So what we're going to do is I'm going to notice that the 7 is a Q. Okay, I want the 25. So this side right here is going to be, well, I'm going to take that thing, I'm going to say, okay, I got the 7 side, and I want to turn it into the 25 side. So it's going to be 25 over 7Q. Okay, so this side's going to be 25 over 7, and it's going to have to be in tension, right? So it's going to be pulling, okay, from the other two sides. Okay, note, I could have also said, well, I know the 25 side here, I know the 24 side is 24 over 7Q. Okay, so I want the 25 side, so I'm going to make this 25 over 24. Those cancel, I get 25 over 7Q, same, okay? So this side is 25 over 7Q, okay? And that's tension. 25 over 7Q, okay? Anyway, so yeah, so this is pretty much it's pretty much how I would do it. Wait, I feel like I've one of these. AB, is AB in tension? Where is AB? What did we decide for AB? Yeah, AB's in tension. Sorry, I wrote this down wrong. Anyway, I have a more formal way of working this out, which I did on the key. It's not really different than what we just did. I just kind of did it in my head, and it was just all from this similar triangles idea. But on the key that I'll post to the internet, you'll see, things that aren't so hand wavy or so Wagnerian. Just kind of like more like the ways that you might want to work it. But some of you may prefer what I just did. It's certainly very fast, and eventually you will probably need to be able to do the way I just did it. But it'll get easier by the time you get there. Anyway, so that's it. Hope this was helpful. And that's it. So, the last thing you should always do in these cases, you should always check this top joint right here. Okay, because if the joint that you didn't do, if you see if it works. So let's see what we've got here, right? So we've got P. So in the X direction, I've got P from this guy. I've got this, the 24 side of that thing. So what was that? That was 24Q, which was going negative, minus 24 over 7Q. All right, and then I've got this one in the X direction, which looks like it was P plus 24 over, so minus P plus 24 over 7Q. Does that equal 0? It looks like that pretty much checks out. Okay, so we're good. Okay, what about the Y direction? Okay, what forces do we have in the Y? We've got this one right here. So we've got a 2Q plus 7 over 24P. Right, and then I've got the Y components of both of these diagonals. So this one is 7 over 24. Oh, that's a minus, sorry. Because it's pulling. Minus 7 over 24P plus Q. And then we've got whatever this one is, which it looks like it's the 7 side here, which is just a Q. Right, so it's going to be minus Q equals 0. Does that check out? We've got two Q's right here. We've got a negative Q and a negative Q, so those are gone, and this cancels with that, so yes. Okay, so that's how you can always figure out if you've got this figured out. So this is good. All right, so I'll post this, and hopefully this is helpful for you guys. All right, take it easy. And, well, probably won't see this in the morning. You probably won't see this at night, so I should say sleep well, but I'll say good morning. So good morning.